Alright, today we'll be looking at the Spdf electronic configuration. Now, under this concept, before you understand this concept very well, you must understand the concept of the atomic structure, energy level, sublevels, and orbitals. These are the 4 things we'll be looking at. But before we continue, please, if it's your first time visiting the channel, please click on the subscribe button so that you have access to over 1,000 of our videos. Alright, so we'll look at this. First thing, what is the structure of the atom? We look at the Bohr model of the atomic structure that says that the atom consists of a dense nucleus with electrons revolving around in circular orbits. You call them orbits or you call them shell, or you call it energy level. So these are shells where you can find electrons. So this area where you can find electrons is what we refer to as what? Energy level. And in quantum mechanics, they say that each of these energy level is quantized, meaning that they have a particular amount of energy that is assigned to each of these energy level. Meaning that the electron here has a particular amount of energy, and the electron here has a particular amount of energy. And the energy here is lower than the energy here. So when an electron moves from this lower energy to this higher energy level, we say the electron is what? Excited. Or you hear about excitation, the movement of electron from a lower energy level to what? A higher energy level. But that's not the discussion for today. Now these are energy level. Now energy level is noted by the symbol what? N. So the first energy level we have N is equals to 1. Second energy level N is equals to 2. Third energy level N is equals to 3. And fourth energy level N is equals to 4. And these energy levels have been denoted by what? Symbols. The first energy level, we call it K. Second energy level L. Third energy level M. And the fourth energy level N. That implies that for our first energy level, N equals to 1, it is what? The K shell. N equals to 2 is the L shell. N equals to 3 is the M shell. And the N equals to 4 is the N shell. For each of these energy level, the maximum number of electrons that they can accumulate is given by what? The formula 2n squared. If you have been following up, we have discussed this. So the first shell can take a maximum of what? 2 electrons, the duplex structure, while the rest can take a maximum of 8, 18, and 32, like that. Now, in this study, we have talked about the structure of the atom, like I said. We have looked at the energy level. Now the sublevel. From quantum mechanics, we're able to understand that there are 4 quantum numbers. We'll be discussing that in another separate topic, but this is an easy trick. Now, the first shell, which is N equals to 1, or let me say each of this energy level N can be subdivided into sublevels. And the sublevel we have sublevel S, sublevel P, sublevel D, and sublevel F. So the first shell, Bn equals to 1, has only one sublevel, and that is what? Sublevel S. The second subshell, N equals to 2, has 2 sublevels, that is S and P. The third energy level has 3 sublevels, and that is S, P, and D. And the fourth energy level has 4 sublevels, that is S, P, D, F. So if we write it here, it means that energy level 1, which is called the K shell, has only one sublevel S, and because it's in the first shell, we say it's going to be 1 S. The second energy level, which is the L shell, has 2 sublevels, that is S and P. And because it is in the second shell, we're going to say 2S and 2P. The third energy level has 3. We have S, P, D. And because it's in the third shell, we're going to have 3S, 3P, and 3D. Now, the fourth energy level has 4 sublevel, and that's going to be S, P, D, F. And because it is fourth energy level, this is going to be 4S, 4P, 4D, and 4F. Now, I want you to know this. When you go to your periodic table, this number you see here determines the period an electron will belong to. An element with electronic configuration that has only 1 S means it's in period 1. That has 2 or 2p means it's in energy level 2. That is period 2. 3, 3s, 3p, 3d. That is period 3. 4s, 4p, 4d, 4f. That is period 4. So the energy level in the periodic table simply represent what? The period. Now, each of this sublevel can actually accommodate a particular number of electrons. And that's what brings us to the concept of the orbital. What is an orbital? An orbital is a region in space where the probability of finding an electron is highest. Where the probability of finding an electron is very high. Is what we call an orbital. Now, for the S orbital, for the S sublevel, we have only 1 orbital. For the P sublevel, we have 3 orbitals. S sublevel we have 1. The P we have 3. That is 1, 2. This D sublevel has 5 orbitals. 1, 2, 3, 4. 1, 2, 3, 4, 5. There are 5 orbitals. The F has 7 orbitals. 1, 2, 1, 2, 3, 4, 5, 6, 7. Yeah. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. The F has 7 orbitals. The S has 1, P 3, D 5, F 7. Now, an orbital can accommodate a maximum of 2 electrons. The orbital having 1 will take 2. That's why the X sublevel can accommodate a maximum of what? 2 electrons. The B having 3 will take 1, 2, 3. That is 6 electrons. That's why the P orbital can take a maximum of what? 6 electrons. The D orbital has 5. So it will take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's why the D orbital can take a maximum of what? 10 electrons. The F orbital has 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's why the F orbital can take a maximum of what? 14 electrons. So in electronic configuration of elements, you must take note of all this. The S sublevel will take a maximum of 2 electrons. The P sublevel, which is divided into the PX, the PZ, and the PY, take a maximum of 6 electrons. The D sublevel has 5 orbitals, so it will take a maximum of 10 electrons. The F has 7 orbitals, so it will take a maximum of what? 14 electrons. And that is because an orbital can take a maximum of what? 2 electrons. Now, in writing electronic configuration, there is an easy trick I want to show you how to know how to use Spdf in writing electronic configuration. Now, if I have this S, P, D, F, the first sublevel, second, third, and fourth. To understand how to write electronic configuration using this is the trick you follow. I'm going to replicate this twice, each of them twice, going from left to right. So I'll have, the first one is the S. So I have S and S. Then I'll move from P to S. I'm going to have PS, PS. Notice that I'm writing each of them 2 times. PS, PS. Now I'll move from D to P to S. So I'm going to have D, P, and S. I'll repeat it again. D, P, and S. Now move from F to S. I'm going to have F, D, P, F. That is the first time. Second, I'll still have, this should be S. I have F, D, P, S. Now, because S is the first sublevel, I'll start with it. I'll start numbering from S. I'll have 1S, 2S, 3S, 4S, 5S, 6S, 7S, and 8S. Followed by P. And P is the second sublevel, so I'll start numbering from 2. This is going to be 2P, 3P, 4P, 5P, 6P, and 7P. Followed by D, third level. So I'll start numbering D from 1, 3, 3D, 4D, 5D. Followed by F, which starts from 4. This is going to be 4F and 5F. Now let's see how we can use this to write the electronic configuration for, let's say, argon, which is 18. Also, let me start with this. I'll have argon will be 1. Remember, S can accommodate a maximum of 2, X2, followed by 2S2, followed by P can take a maximum of 6, 2P6, followed by 3S2, followed by 3P6. So let's count. 2 plus 2, 4, plus 6, 10, plus 2, 12, plus 6, 18. That is the electronic configuration for what? Argon. What if you are giving element X with electronic configuration of 30? I think that should be same. 30. We'll start. We'll say 1S2, 2S2, 2P6, 3S2, 3P6, 4S2. Let's calculate. 2 plus 2, 4, 10, 12, 18, 20. So we're left with 10. So we're going to have 3D10. So that is the electronic configuration for what? Earth. Now, they will ask you, which period does this element belong to? Now, you don't need to think. It's going to belong to the period. The outermost shell is the highest energy level. We have first shell 1, second shell, and this is the outermost shell 3. So it's going to belong to what? Period 3. Which group is it going to belong to? Because this is the outermost shell, the group is determined by the number of electrons in the outermost shell. So the outermost shell is energy level 3. So it's going to be 2 plus 6. And that's going to be what? 8. So this element will be in period what? 3, group 8. You understand? So this is how to go about the electronic configuration of element using the Spdf. And this is the easy way to understand it. If you have any question, please leave it in the comment section. Meanwhile, if you are yet to subscribe to this channel, please do so. There are thousands of videos you have access to as soon as you do that.